Welcome to Keeping Current, an ERS and HVM podcast designed to plug you into the world of electrical power systems. I'm your new co-host, Fred Toepfer, and whether you're an industry professional or simply fascinated by the advancements in engineering, this podcast is for you. In this episode, we discuss how safety first is more than just a slogan, it's a commitment, and why regular updates and collaboration are key to safer electrical systems. Joining me for the discussion today are Dennis Salzmann, the Director of Business Operations and Strategy at ERS with more than 24 years of experience, and Mark Owens, a Supervising Power Systems Engineer at ERS with 35 years of experience. Welcome, Mark and Dennis.
Hey, Fred.
Thank
How
you, Fred.
doing?
Today, we will discuss their insights on how collective experiences, field challenges, and the latest NFPA 70E and B shape the safety of arc flash compliance. So get ready to unplug and connect. Welcome to Keeping Current. I've been involved with the electrical arc flash compliance programs for almost 20 years, and a lot has changed in that time. We've gone from not really having a clue how to protect ourselves to having better tools and equipment to allow us to be able to do that. Because of that, I just wanted to relate an experience I had from early on when I started in this business. I was in a coal field in Gillette, Wyoming. I was with one of my coworkers, and we went out and looked at some switchgear with one of the electrical maintenance supervisors from that company. And when he opened that switchgear cabinet, coal dust came out in a plume, and I started thinking to myself, I wonder what the conductivity of coal dust is, and I could feel my heart rate going up. Well, he didn't stop just there. He decided he wanted to lean down and look at the nameplate on this equipment, so he had to use his hand to clean the nameplate in order to be able to read it. And he had a piece of metal, something was hanging from his shirt. And when he bent over, it was kind of dangling. So all that did was make my heart rate go up a little bit further. Luckily, nothing happened. In fact, I moved away from the front of that enclosure and away behind where the door was, as did my coworker. And fortunately for us, there wasn't an accident that caused anybody to get hurt. What I learned from that is that NFPA 70E is not just discussion on paper, and doing an engineering model is just not an engineering exercise. I actually felt what it felt like to be in danger by being exposed to a potential arc flash hazard. And ever since then, I've had that in my mind anytime I talk to anybody, whether it's people in my company or customers that we talk to let them know the importance of arc flash safety. Dennis, you've been out in the trenches in the course of your career. Can you share your experiences and how the industry has changed with regard to electrical safety?
Yeah, actually, I can probably relate to that maintenance supervisor that you were talking to, or sharing that story with. And I've done probably stuff similar to that. Back in those days, whether it be in the Navy or when I first got out and started working in this industry, it was really a matter of, hey, let's just get the work done. And so we just did what we had to do to do stuff, and we didn't really think about it. Even though safety was there, it was kind of like you said, it was something that was more on paper and maybe something we kind of paid attention to. But again, it was about getting the work done. And studies were really more, in my opinion, meant to contain the selective coordination and containing the fault closest to, tripping a breaker closest to the fault, and not really about my safety. And so I think that's where the industry has really evolved today to going, hey, safety is first, getting the job done is second. And we see that in 70E and even in 70B with the hierarchies of control and eliminating the hazard versus just go grab your PPE or not even use PPE, just go get the job done. And so that's, like I say, I can relate to that guy.
Excellent. Good perspective. Mark, what do you think?
Yeah, very similar here. I can remember back in those days, early on in my career, we would test energized gear. Of course, the arc flash hazard was there. It just wasn't as well known. Another classic case of ignorance is bliss.
Great insights, guys. Appreciate that. And I think, as we're all fond of saying within our organization, at the end of the day, we want everyone to go home safely. Let's talk a little bit more about the present day. How does arc flash safety differ for those directly exposed to hazards? Dennis, you got a comment?
Yeah, I mean, as I was saying before, right, if you look at 70E, It's really about eliminating the hazard instead of just going and grabbing your PPE. And as Mark was saying, we used to do stuff energized. Well, 70E, the way it's really written is they want you to not only remove that hazard, but if you're going to do energized work, you really have to justify it, right? It can't just be because we're saving money or because I don't want to. There really has to be a greater risk that would allow you to go ahead and work energized. And you've got to get a lot of sign-offs, right? You got to get supervisors and customers. Everybody's got to understand what you're doing, and you got to put out a procedure for it. You just can't go do it and get that job done. And so I think, from my perspective as a former field person, being able to go out and go, okay, I've identified the hazard, I can work it safe, meaning I can go home safe at night and I can still get the job done, is really a great way to marry those two together.
So another thought I had was, what challenges do we typically encounter between what's designed on paper and what's observed on site? Mark, can you comment on that for us?
Sure, Fred. Yeah, something more common today, due to the material shortages that are still very common. More than ever, we are finding significant discrepancies between the equipment ordered based on the design and the actual equipment delivered and installed on site. So not all breakers are created equal. Seemingly subtle differences in breaker and or trip unit models can lead to significant differences in system performance and therefore arc flash results. For example, the system design may have specified a full function circuit breaker with full LSI protection, but the breakers that are shipped may only have very simple functionality. May not seem like a big deal, but this slight change can have a huge impact on the arc flash calculation results. Accuracy of data for the study is critical.
Just to add to that, when a breaker fails and somebody just grabs a breaker off the shelf and throws it in, it may or may not be the right rating or what the study was based on, and people don't necessarily always pay attention to that.
Very good point. Yeah, any changes to the system may warrant revision or a refresh of the system study. So yeah, simple changes can impact the results. Good point, Dennis.
And I think a lot of maintenance folks, right, they get into that habit of, oh, that breaker was tripping, so let me just go adjust the settings, when there could be something actually wrong, downstream in the system that they should be looking at, and changing those settings. I mean, that used to be very common practice, and hopefully that's not happening today, because as you say, that can really affect the study.
Absolutely, yeah. Even setting changes, like you said, can impact the results and therefore impact the PPE required to work safely.
I often tell customers when we start to work with them on a project that this is really a team effort. It's not only the things we do to implement an arc flash project, but it's also the responsibilities that they have to help us move this project along. It's giving us access to their site. It's getting utility data. It's approving preliminary reports when we finish that. It's allowing us on site again to install labels, or if there are mitigation strategies like replacing underrated breakers. We need to have that information so that we can make this project go as smoothly as possible. So guys, I wanted you to, at least if you can, give me some examples of constraints we encounter in executing an arc flash project and suggestions we can give to users to remove those constraints so they get a better project execution that's done on time to their satisfaction. Mark, what are your thoughts?
Yeah, Fred, similar, like we just spoke of the importance of accurate on-site field data, utility short circuit fault duty data is the true foundation for short circuit and arc flash analysis. Using assumptions for utility data can lead to drastically inaccurate calculation results. We are often asked to use an assumed worst case value for the available utility fault duty. Often our clients will say, yeah, just use whatever the worst case is. That's not always best. Very often, greater available fault utility data does not always lead to greater arc flash hazards. Arc flash incident energy calculations are often counterintuitive. Stronger and or medium voltage systems do not always yield the greatest arc flash incident energy compared to weaker and or low voltage systems. So what may seem like a more dangerous system in regards to arc flash, it's not always what it seems. It's very counterintuitive. So be careful, be cautious.
And to go along with that, Mark, right? I mean, if you have a higher if the incident energy is actually lower, but we're saying it's higher, and now you're working, if anybody's ever worked in a blast suit, I mean, it's extremely uncomfortable. They're hard to see and they're hard to hear what's going on. And so it can actually create an unsafe environment, making your work more difficult and harder to do when you don't have that accurate data. So it's really important that we really know what the true hazard is. And then to go also along with that, if you're not doing a study and you're using the NFPA 70E tables, you still have to collect data, and it has to be accurate for those tables to work, and they only work on low voltage. They don't actually work for medium voltage. And you've got to know times and upstream breaker settings. And so you just can't make assumptions and assume you're going to be in the right PPE.
Exactly. And you still need to know short circuit fault duties for those tables as well. So there's no getting away from that. You need accurate data regardless.
And I said, as Dennis and Mark have attested to, there's so many opportunities for the user to help us in effectively executing an arc flash project. Again, it's a team effort. And at the end of the day, we want you to be satisfied with the service that you get from whomever you use to perform the compliance analysis and do it as efficiently and as effectively as possible. Let's talk about the standards that drive arc flash electrical safety as directed by OSHA. So Dennis, do me a favor. Can you explain the role of NFPA 70E and 70B standards related to electrical safety and how they work together?
Yeah, Fred. I mean, 70E, right, is what requires us to do the study or determine what the PPE is. And then 70B is the maintenance of that equipment. And as of this year, as most people know, 70B became a requirement. Before it was just a recommendation. And really the foundation, in my opinion, are these two together. Because if you only do one, then there's no guarantee the other one works. And so if you do breaker settings, but you don't do the maintenance that goes along with it, who knows if that breaker is actually going to trip? And again, if you do the maintenance on it and you know that breaker is going to trip, but you don't have it set accurately, then you don't know if you're truly protected from an arc flash event and when that breaker is actually going to trip because it's not set correctly. So the two really go together to determine that the system's going to work correctly and you're in the right PPE.
So Mark, let me ask you, how important is it to make sure that all equipment is maintained and functions according to specifications?
Oh, Fred, that is super important. All these calculations, of course, are based on some crazy, crazy equations, stuff that I have nightmares about, and I love numbers. So, but some crazy stuff. But two main parameters for our arc flash calculations are basically fault current and time. And where the time comes into play with maintenance is, again, the operation of the protector devices. All these calculations are based on the circuit breakers tripping when they're supposed to. And the only way you know if those breakers are going to trip correctly is if you do proper maintenance and testing. So again, maintenance and testing of the equipment and the power system is critical and a critical component to ensure that your study will be accurate.
Folks, this is what you get when you have two guys with 24 years and 35 years of experience. A lot of great insight, and I've depended on them a lot in my career to help us do our job when we're doing arc flash implementation. So I appreciate what you guys have imparted to the listeners today. One of the items within the NFPA 70E standard that I pay particular attention to is the mandatory 5-year update. And even though the standard states that significant changes happen in your system, you need to go and update. It seems like a lot of people fixate on just doing this every 5 years as if it's just a one-off, or maybe they wait 5, 6, or 7 years. And what happens when you do that is when you come to the 5-year update, you really haven't documented the changes that have happened to your system. Maybe the person who was responsible for implementing that update is no longer with the company. And I hear a lot of people tell me that nothing has changed within their electrical system. That might be true for the physical system itself, but it's the things that you can't see. Has available fault current changed? Has somebody gone in and changed the setting temporarily on a interrupting device because of a temporary nuisance outage? Is the available fault current increased such that some breakers that would have interrupted the fault before will no longer do that? Those are the kind of things that you don't see. So what we have is some users take the approach that rather than waiting every 5 years, we do it once every year or maybe even more frequently than once a year. And what that means is they are keeping up with the changes in their system. Most of these on a year or a part year basis are incremental such that they can collect the data and they can provide us the information. What we can do is actually do an incremental study which can be attached and appended to the original 5 year update so that as you do this all along, by the time it gets time to do the next one in 5 years, you have collected all the data. You don't have to go back and look for it. And it's less expensive to do that 5 year update as opposed to starting from scratch or reinventing the wheels. So what you get is ongoing safety, ongoing operational excellence, and you get to do it for less cost. And remember, this is not a one and done every 5 years. This is a perpetual program so that if you find a way to manage this properly, you get the benefits and you get it for lower cost.
And Fred, one of the ways to do that is if you marry it with your maintenance. If you're doing maintenance, let's say every 3 years, what better time to collect data? Your system's down, you can get in, you can get accurate cable sizes. You can, even just do an audit on the system. You can look at the breakers, make sure they match, get the settings in them. And so that's one way to marry the two together to make sure your data is very accurate. And it would reduce your cost, right? Because now you're collecting data at the same time you're doing the maintenance versus having to go out and collect data separately.
Yeah, Dennis, I agree with you. And it's one of the things that we often try to bring up when we are looking at providing electrical services. Don't just think about doing this one aspect of maintenance and service. Look at the other things that could be done at the same time. You mentioned testing. Maybe some of that might be infrared and other things. So whenever you're looking at doing arc flash, it's an opportunity to marry other service capabilities in there. And potentially you're going to have a better operating system and you're going to do it for lower cost.
Yeah, well, and if the goal is to send people home safely, right, that should be the driving force, not just the code to do it every 5 years. It really should be the safety of personnel.
Yeah, just to sum up what I've said, accurate data and study analysis, maintenance, and testing are all critical components of helping make an electrical power system safe and reliable.
I agree with you 100%. Great discussion, guys. I really appreciate your insight, and I think the attendees to this podcast will find it beneficial as well. So just to recap what we talked about the evolution of arc flash safety and its relevance today, insights from engineering and field perspectives, the role of timely data and protocols in safety, and the importance of adhering to NFPA 70E and 70B standards with regular updates. I think if you do these types of things, you're going to find that you're going to get excellent results in terms of safety, operational excellence, and manage your costs accordingly. That's a wrap for this episode of the Keeping Current podcast, designed to plug you into the world of electrical power systems. I hope you were able to find our conversation and engineering perspective about arc flash compliance valuable. Thank you to Mark and Dennis for sharing your experience. If you'd enjoyed this episode, be sure to subscribe, rate, and leave a review. And don't forget to tune in every other Thursday for more expert knowledge and industry updates. You can also connect with us on LinkedIn to join the conversation and stay updated on the latest episodes. Thanks for listening. Until next time, keep current.